Hello and welcome to this Edexcel Further Maths Statistics video, part 2 of the video looking at hypothesis testing with the geometric distribution. And so if you recall, this was the example that we looked at in part 1, so you might like to just pause for a moment and read that through and familiarise yourself with the example we were looking at again. And in this part of the video we're going to be looking at the critical region approach to carrying out the hypothesis test procedure. And if you recall, our hypotheses were that P was equal to 5.5% or had decreased, so it was less than 5.5%. So we had a one-tail test. Our significance level was 10%. And the test statistic, the event that we were basing our calculations on, was the fact that the first effective product happened on the 48th sample. And so we have here the summary of the beginning of this procedure. And now the question is how to find the critical region. So for capital X, which follows the geometric distribution where P equals 0.055, we wish to find an outcome little x so that our random variable equals or exceeds little x. So we find our first effective sample on the x or beyond the x sample. That probability has to be less than or equal to our significance level of 10%. And that quite clearly implies this statement here, that the probability that our random variable exceeds that value little x minus 1 must be less than or equal to 10% as well. And therefore we can turn that inequality round and say that means that the probability our geometric random variable capital X takes a value less than or equal to little x minus 1 has to equal or exceed 0.9. And it's worth just spending a moment and making sure you're quite comfortable with that process of coming to this particular statement here, which is the easiest point to work from when we're trying to find such probabilities. So just as we did before, looking at geometric probabilities on Geogebra, and this time setting our P as 0.055, we can look at a different range of values for n, for how many failures, if you like, or non-successes or non-defective items we need to happen. And we can then plot this outcome here, where it will give us the cumulative probability that x minus 1 is less than or equal to particular values for n, and we are looking for one, or the first one, that exceeds 90.90, 90%, and you should find that n is 41 is the first outcome that gives us the probability of x minus 1 being less than or equal to it at 0.9017. So we found on Geogebra x minus 1 had to be greater than or equal to 41, and that gave us x equals 42 or greater than 42 for our critical region. If we look at solving the problem algebraically, if you recall, this was the statement that we came to, that we would need our random variable x to be greater than little x minus 1 with probability less than or equal to 0.1, and that comes from our significance level. And that in this case would mean we need to find the point at which we've had a whole sequence of products that are not defective. For every single sample, we need that probability to be less than or equal to 0.1, and we need to try and work out the power here that we're looking at. So the probability of being non-defective would be 1 minus 0.055, and therefore this statement that we looked at here is translated mathematically into 0.945 to the power x minus 1, all x minus 1 being non-defective. That has to be less than or equal to 0.1. And if we take logs each side there, and remember to reverse the inequality sign, because log 0.945 will be negative, and when we divide both sides by that, obviously we're going to change the inequality to a greater than or equal to 2. We will end up with x minus 1 greater than or equal to log 0.1 over log 0.945, and that gives us x minus 1 greater than or equal to 40.7. So x is greater than or equal to 41.7, and that again gives us x equals 42. Just as, I know it's slightly confusing, but with Geogebra, we also ended up with x being greater than or equal to 42. And that means that 42 is the first point at which we need to find the first effective product. For the probability of that to happen, or for our first effective product to occur at a point beyond 42 samples, that probability is less than 10%. And so 42 is the beginning of our critical region for this test. And so the critical region can be written 42, 43, 44, any occurrence, first occurrence of a defective item on the 42nd or beyond sample is going to occur with a probability less than 10%, and so this is our critical region. And obviously 48 definitely does lie in this critical region, so there's significant evidence to suggest that the defective rate has decreased from 5.5%. And that concludes this video.